Okay, an old water tank is leaking. The level H meters of water at time T hours is decreasing at a rate proportional to H squared. So very simply, you just need to think about this tank. Okay, it's leaking, it's got water in it. Okay, and the height of the water is H. That's what it says here, the level H meters of water at time T hours. Now, of course, because it's leaking, H is going to decrease, isn't it? Okay. And we have got information here explaining how it decreases, the rate at which it decreases. So in other words, how it decreases with respect to time, yeah? So when we set up a differential equation, we're going to look at how H changes with respect to time, okay? And we've got that proportional word again, right? So we're going to put an alpha there. And because it's decreasing, it's going down. Okay, so dH dt will be negative, yeah? It's got a negative gradient. If it was a curve, you'd see it falling. So you'd have a negative gradient there. And proportional to then H squared. So that's explaining the relationship then between how the height is changing over time, okay? It's proportional to this here, okay? Now, we need an equation, so we've got to get this equals. So don't forget then you bring in the constant k. Alright, always do that. So we get an equals here. Okay, so in B then, they want us to solve the differential equation. Okay, so let's separate the variables as we've done before. So separate the variables. Okay, well we have the h's on one side, so this is h squared. Let's take that over. H squared's on top here, yeah? Take it over, and we've got 1 here, so 1 over h squared with respect to h. Keep the minus k there, and take the dt up. Okay, right, so then we're going to integrate both sides, okay? Now, it's h squared on the bottom, okay? So it's not going to be ln, because it's not linear on the bottom. If you remember, all you have to do here is take that up, so it'll be h to minus 2, yeah? And then we can integrate it as normal. Okay, so do that first. And of course, h to the minus 2, well, when you integrate, you add 1 to the power and divide by that new power. Okay, so if I add 1 to minus 2, I get minus 1. Divide by minus 1. That will equal to then, well, minus k. Integrate it as minus k times t then, yeah? Okay, because minus k is a constant. So integrate it, you get minus kt. Don't forget then, there's no limit, so you need to have an integrating constant there, okay? So what I'm going to do here now is, I'm going to make this look a bit nicer. I'm going to put the minus in front, and because it's h to the minus 1, I'm going to take it down. So that will be 1 over h, okay, because it's negative 1. So you can take it down as a positive power down here then, positive 1, equals to minus kt plus c. So then we can look at the information we've got here. It says, given that the height was 1 meter when the tank sprang the leak. So when the tank sprang the leak is at the beginning, yeah? When this all starts to kick in. So in other words, when t is 0, h was equal to 1, okay? So sub it in here, so we have minus 1 over 1 for h equals to minus k times 0 plus c, which means then c will equal to minus 1. So we have minus 1 over h equals minus kt minus 1. Now when you see this here, what I'm tempted to do is, I'm sure you'll look at this and think the same is, let's just make everything positive, okay? So we're allowed to do that because you're doing the same thing to everything in the equation, okay? So let's just say then, you know, change the signs, divide through by minus 1, okay, if you want to write it like that. So you have 1 over h equals to kt plus 1, okay? Now, we need to work out the constant k in order to solve the differential equation. And it also says 80 centimeters is the height when t is 4 hours. But remember then what things are measured in. T is measured in hours, height is measured in meters. So this 80 centimeters, remember to change that to meters, okay, 0.8. So we say, look, when t is 4, h is 0.8. So we'll have 1 over 0.8 equals to k, which we're going to work out, and t, which is 4, and then plus 1. Okay, so in other words, 4k is equal to 1 over 0.8 take away 1. I take that over. So if I work this out on my calculator, I get k to equal to 1/16. Okay, so then I've worked out my k. Let's go back to them. So therefore 1 over h is equal to 1 over 16 for k, t plus 1. Now it says solve the differential equation. So in other words, we need to get h equals. This is not h, yeah? It's 1 over h. So we need to somehow take that h to the top. The way I would do that is just look at this side first and think, oh, okay, let's try and make this so that there's no fraction here. Okay, get rid of that. So what I'll do is if I times through by 16, okay, everything by times by 16, so I'll have 16 over h. If I times this by 16, it'll become 1, so 1t, and times that by 16. Okay, so I get that. I just times through by 16 and I've got that. And what's good then is there's no fraction here. What I can do then is I can flip this. So if I flip this, I get h over 16. Okay, by flipping that. But I have to flip this side as well. So if we see this then as t plus 16 over 1, because that's what that is, isn't it? I can write it like this then by flipping that. And then all I've got to do is take that 16 up. And I've got this here, and I've solved my differential equation. It says then, find the time it takes for it to reach half its height. Well, half its height will be 0.5, half its original height, because remember at the start it was 1 meter. So half its original height would be 0.5, 16, t plus 16, and then it's a case then of taking this up here, just doing a bit of algebra then to work that out. So you've got 0.5 times t plus 0.5 times 16, which is 8, and that equals to 16 there. So that implies then that 0.5t is equal to 8, so then t will equal to 16 seconds.